Rise and shine, porcupines. You know what time it is. It's Algebra with Al time. And I'm your host, Al Rosetti. Today we're looking at Chapter 2, Unit 8. Graphing linear and absolute value inequalities. So after watching this video, students will be able to graph linear inequalities and absolute value inequalities. So the concept is inequalities. The skill is being able to graph them. So I'm excited. Why do you say we get started? Here we go. All right, so we have our first inequality is y greater than 1. Now when we graph this, let's look at it like it's y equals 1. That's where we're going to draw our line. Now the difference between an inequality and an equation, a linear equation, is you have to decide when you draw your line, is it going to be a dashed or solid line? Now, if you do not see the equal sign under the inequality, it's a dashed line. So I teach it where if you don't see a line, you don't draw a line. You draw a dashed line. So we're going to draw a dashed line right through positive 1 on the y-axis. Now, think about it. Where are the bigger numbers on a number line? Are they above or below? And they are above. So y greater than, so we're going to shade above the line, and that means every area shaded on that graph, everything shaded, would be a solution to that inequality. And the reason why we graph inequalities is because there are an infinite number of solutions. How would you show an infinite number of solutions if you didn't graph it, right? So that's why we graph it. For an equation, there's only one solution. We can write x as 1. We can't write x as 1, 2, 3, 4, 5, 6, 7 to infinity, right? So you have to graph it. All right, number 2. So we have the equation y less than or equal to x plus 2. So our y-intercept is 2, our slope is 1. So we'll put a dot at 2. Now we know how to draw our line. Is it dashed or solid? Well, what I say, see the line underneath the inequality, you draw a line. You don't see it, you draw a dashed line. Now, it's less than or equal to. Look at the y-axis, right? Where are the lower numbers? Are they below or above? Well, obviously they're below, so we're going to shade the entire region below. And once again, that's the solution region. Number 3, x plus y less than or equal to 4. Before we can graph this, what do we got to do? We got to transform it into slope-intercept. So to do that, what are we going to do? We're going to subtract x from both sides. We have y less than or equal to negative x plus 4. So our y-intercept is positive 4, and our slope is negative 1. So let's put a dot at positive 4. We're going to go down 1, right, and over 1. Now, ask yourself, is it going to be a dashed or solid line? Well, we see the line under the inequality, and the way I teach my students, you see a line, draw a line, right? Pretty easy to remember. Okay? Now, it's less than. So where would we shade? Obviously, the lower numbers are below, and so that's where we shade. Okay, x plus 3 less than y. Now don't be confused because the y is on the right side. This is already in slope-intercept form, and if you feel like you need to rewrite it so to make it more comfortable for you, so y greater than x plus 3, then go ahead. But you don't have to. It's already written in slope-intercept, even though it's written in reverse. So our slope is 1, our y-intercept is 3. So we're going to put a dot at 3. We're going to go up 1 and over 1. Now we have our 2 points. Is it dashed or solid? Well, you don't see a line. Don't draw a line. So it's dashed. It is greater than, so we're going to shade above. And there you have it. Every coordinate in that shaded region will be a solution that makes that inequality true. And there's an infinite number of solutions. All right, number 5, 2 minus y less than x. We have to put in slope-intercept form, we'll subtract 2, but we cannot let y stay negative. So we have one more step here. Although it looks like it's slope-intercept, and it is, y cannot be negative. So the math behind that is to divide everything by negative 1, changes all the signs, and don't forget, it flips the inequality. So y greater than negative x plus 2 now. And if you don't flip the inequality, you could do all your math right, your graph is going to be wrong. So now our slope is -1, our y-intercept is 2. We draw our points in there. Now, it's going to be, instead of below, right, because we switched it to greater, it's going to be above. So everything above that line is going to be a solution to this inequality. So we're going to shade everything above. There you go. So any coordinate you choose in that area will make that inequality true. All right, number 6, y greater than x, okay? So all we're going to do, we know that the slope is -1, the y-intercept is 0. It's greater than, so what are we going to do? Where's the greater numbers? Are they above or below? Obviously, the bigger numbers are above. Shade everything in that region, and there you have it. Every value in that region is a solution. All right, number 7, x plus y greater than 2. Now, is that in slope-intercept form? No. What do we do to put it in slope-intercept form? Well, we got to subtract the x, and once again, you see that y is negative. We cannot end up with -y. So you have one more step. Now, and no teacher, no math book, nobody's going to say that you need to do this. This is something at this point, at this juncture, you have to just know that. You see a -y, you have to multiply everything or divide everything by -1. No one's going to tell you that. Okay? All right, so when we're done here, we have y less than x plus 2. Once again, our slope is 1, our y-intercept is 2. Remember that multiplying by a negative or dividing by a negative flips the inequality. If you don't flip it, you got all this math right, but you don't get 100% because your graph is going to be wrong. All right, so once again, where are the lower numbers? Are they above or below on that y-axis? Of course they're below. So we're going to shade everything below that line, and every value, pick any coordinate you want in the shaded region, plug it in for x and y, it will make the inequality true. All right, 9x plus 3y. Okay, -6 less than 11. Okay, I'm sorry, less than 0. I don't know what I was looking at. So we have to put this in slope-intercept form. To do that, we're going to add 6 over. We get 9x plus 3y, right? Less than 6. So in the end here, you have to get y by itself. Subtract 9x over. Then we have 3y less than -9x plus 6. Now subtracting the 9x does not flip the inequality, right? So now last step, divide by 3 to get y by itself. And in the end, you have y less than -3x plus 2. So our slope is -3. Our y-intercept is 2. Now, take a look at it. Ask yourself, are we going to graph a solid or shaded line? And what do I say? If you don't see a line, you don't draw a line. Draw a dashed line. Okay? So we draw a dashed line. Now, we flip the inequality because we did not flip the inequality on this. So we're going to shade below. And the key is look at the y-axis. Where are the lower numbers? Are they above that line or below it? And if you keep that in mind, your shading will always be accurate. All right, number 9. Looks like we're going to have to transform this into slope-intercept, right? Can't do it the way it is. So we want y by itself. So the simple thing to do here is what? Subtract 1 from both sides, and now it's slope-intercept. What I'd like you to do, really, look at that problem ahead of time and take a step back and ask yourself before you even get going on it, are you going to draw shaded or dashed, right? Are you going to shade above or below? Take a step back and look at it and analyze that stuff before you start. That way you don't make mistakes. All right, so there's my graph of the line. I start at -1, I go up 2 and over 1 to draw my line. There's no line under the inequality sign, so if you don't see a line, you don't draw a line. We shade above because the greater numbers are above. And there are some nice graphs of what we just did. So, because mine are a little sloppy. All right, number 10. So y minus 7 less than negative 9. What are we going to do to put this in slope-intercept form? Now you don't see any x's, so you might say, what do you mean? But we're going to add 7 over. So all that means is what? There is no slope. It's a straight line right through negative 2. Is it a dashed or solid line? Well, you don't see a line, you don't draw one. So it's a dashed line, right, at negative 2, and it's a straight line. Now where do we shade? Above or below? Well, it's y less than. So where are the lower numbers on the y-axis? They're below. Shade below the line. There you go. A couple of simple things to follow. All right, number 11. I have x greater than negative 5. Think of it as, okay, where's x? Where's negative 5 on the x, right? And no matter what value I pick for y, x will be negative 5. So if I pick 1 for y, x is still negative 5. If I pick 2 for y, x is still negative 5. So it's a vertical line straight up and down. There's no slope. It is undefined for this equation. But greater than in this case is to the right. Bigger numbers are to the right. And there you have it. All right, our last one is an absolute value inequality, right? Y greater than the absolute value of x. Now we already know, we've gone over what the parent function of this is, right? The parent function of this is start at 0, 0, right? And go over 1 and up 1. Over 2, up 2. To the left 1, up 1. To the left 2, up 2. So this is an absolute value, and there's really nothing more to do if you understand the parent function. If you don't, you're forced to use a table of values, plug in negative 2, and you get positive 2. Plug in negative 1, you get positive 1. This is one of the easier ones to recognize. There really shouldn't be any reason why you have to do any calculations here. Simply know the parent function and draw it in. And there's not one teacher that's going to say anything to you if you say, that's the parent function, and that's why I did what I did. In fact, they're probably going to give you high praise because nobody does that. So, that's all I have time for today. Thanks for coming, and remember, math, 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 get up and do some math.